Now let's really study first-class continuations. To know continuations as values, we need to define a new language. So this language is called KFAE. FAE with continuations as first-class values. So the concrete syntax has the usual FAE syntax and this new language construct. New language construct to introduce a continuation. Now you should ask, what about the other language construct? Whenever we introduce a new language construct, we said that there's going to be an introduction and use. So when we have, at least one of use. When we have numbers, we used it with addition and subtraction. When we have function expression, we call it. When we have identifier introduction, we used it. What about this continuation? What does that mean? What is it? So with this language construct, we can introduce a continuation value and we can use it reusing this language construct. Why is it so? What is this language construct and what does that mean? The concrete syntax says open, close, and we have VCC keyword and ID and semicolon and expression. So the semantics of that is we are introducing new name here, ID. And we have this open close, meaning that this ID has effect in only this expression. Outside these curly braces, this ID does not have any effect, does not have any meaning. So that's the static scope of this name. And while interpreting this expression, we may encounter this ID. It's just like what? Val ID. Now I forgot the syntax, but yeah, let me just say whatever I want to say. Semicolon and expert close, meaning that we are introducing a name whose value is the value of this expression. Remember that ID's value is this expression when we interpret this expression. Remember? Yeah, this is just the same as what? Function call. Function call of, let's say, expert 1 and expert 2, right? Remember, it's just like parameter ID, and then body is what? Expert 2, and the argument is, the argument is expert 1. So ID's value is expert 1's value. Using that information, interpret expert 2. That's all we know, right? But what about this one? We are introducing a new name. What's the value of it? Oh, and we are going to use ID in this expression. Then, when we see that ID here, what's going to be the value of it? The value is going to be continuation. The value is going to be continuation we are supposed to do when we are done with the evaluation of this expression. One more time. The semantics of this expression is the value of ID is a continuation which is supposed to do after done evaluating this expression. So the value of ID is a function that takes a value of this expression and then do the next thing to do. So when we encounter ID while interpreting this expression, then what we are supposed to do is that that's a function value, continuation value, which takes a value and then do the next work here. Just skip the remaining thing here. Is it clear? Let's see some examples. Open, close, okay. VCC, we are introducing new continuation here, whose name is K. So what? K's value is a continuation, which takes a value and then do what we are supposed to do here. What are we supposed to do here? Return the value of this expression, right? So K is supposed to get some value and return it. That's it. Then, using that information, let's interpret this expression. That's an addition of E1 and E2. That's an addition of E1 and E2. The value of 1 is, 1. The value of K2, this is the use of continuation K, right? The syntax is just like function call. What's the value of K? Oh, I know. The value of K is a continuation that takes a value and then go here, meaning return it. The value of K is get the value 2 and then return the value 2. That's it. Forget about the remaining work. That's the meaning of continuation. So the value is not 3 but 2. Surprise, right? That's the difference between usual function call and continuation call. Continuation meaning we do not go back to the caller. Continuation meaning we forget about the past, no way to return, just burn the bridge and just do K. That's it. It may not be clear to you, I know. Let's see more example. This is a bit more complex example. If you don't understand this with the first explanation, don't panic. Most of the people did that. Just take your time and study and ask questions at the piazza board or use the office hour. Because, I'm gonna repeat this in Korean and move on. 컨티뉴에이션이 되게 특이해서 여러분이 많이 보지 못했던 거예요. 그래서 뭔 소리야? 못 알아들을 수 있어요? 흔들릴 필요 없어. 첫 번에 알아듣는 사람 거의 없어요. 그러니까 이 온라인 렉처라서 좋잖아요. 다시 돌려보고 다시 들어보고 모르면 우리 조교님도 훌륭하신 조교님들한테 오피스 아워에 물어보세요. 근데 어쨌든 저는 이건 한 번만 설명할 거예요. 온라인 렉처라서 저도 좋아요. Okay, let's see this. What does this example do? From here to there, we are defining continuation named done. Done meaning that it's a continuation. It takes a value and then return it. Don't do anything any remaining work. Okay, done is that thing. What about VCC, ESC? Oh, okay. Let's see. This is a function call. Function call and ESC is another continuation saying that's the work when you are done with the evaluation of this part, right? From here to there. What is the work to do? Get the value of this purple, this is purple, okay? Get the value of this purple and then apply 3 to that, meaning that the value of this box would better be a function or continuation, right? We are gonna pass 3 to that and that's it. That's ESC. Okay, good to know. What are we supposed to do next? It's a function application. Ooh, continuation application. What is done? Remember, done is evaluate the argument, get the value, and return it. Okay, meaning we do not do function application or something else. Just return it. Okay, what's the argument? It's 1 plus this one. Okay, yet another VCC. What is K then? K is this one saying that evaluate this blue box. This is blue, okay? Evaluate this part, get the value, add 1 to that, and then return it. That's the work to do. Wow, so we have done ESC and K. We have 3 continuation values. What are we supposed to do next? This one. What is that? Application of continuation. Okay, What is continuation? ESC. Remember ESC? Yeah, that was that outside the purple box. ESC, get some argument, right? Get the value and apply 3 to that. Remember? Yeah, get the value k and apply 3 to that. Okay, what was k? K was get the value and add 1 to it and be done with it. Oh yes, so we have 3, add 3 to 1 and be done with it. So the result is 4. It's crazy. Yeah, I know. And we are going to implement this language in Scala, and we are going to have the second break. And then finally describe the semantics of this KFAE in a small step of operational semantics. Then you're going to be done for today. Yes. Well, you know, Monday's lecture was short because today's lecture is dense. So stay tuned. Let's see. This is our abstract syntax for KFAE. The usual FAE and VCC. The continuation name and an expression to evaluate. Right? Now, yes, we have new kind of value because it's first class continuation, right? First class continuation, meaning continuation is a value. So remember, we could say x plus 1 apply to 4, or we could apply k4 when k is a continuation. So closure v and cont v, they are both like functions that can take arguments and do some work. But the difference is this closure v, we created it. We created this function, so we know its parameter, we know its body expression. So closure v takes a parameter, body expression, and even the environment when this closure v was constructed. But cont v, it's a continuation. We don't know its parameter, we don't know its body, we don't know its environment, we can just call it. Why? Because its type is a lambda expression in Scala. Remember, when we implement that interpreter env and k, right? That k, we constructed that. Really? Yeah, really. Because when we interpret L1 plus L2, right? We said interpret L under the environment. And what did we say? LB, L, ba, ba, ba. That was the lambda expression. That was the continuation that we created. That's that value, arrow value that count. So when we capture that as a value, it's gonna be this lambda expression, not like parameter name, body expression, and environment. Those two, closure v and cont v, they are both like function thingy that takes an argument and performs some work, but this is language function and this is an implementation function. If it's not yet clear, let's see how we can implement that. That's gonna help you understand that better. So one more time, where do we want to say? Here. In KFAE, there's only one language construct to introduce continuation, and there is one use sign for continuation. So in the concrete syntax, we had to add only one language construct. In the abstract syntax, we had to add only one language construct because use sign is gonna be reuse the existing function call syntax, right? So this could be, look at that, this is function call, right? E1 open, E2 close, E1 open, E2 close. Then here, evaluation of E1 may result in what? Any value. And in this KFAE language, how many kinds of values do we have? Num v, closure V, and cont V. So three kinds of values. So when we interpret this first sub-expression, let's say this inner green box, the value is gonna be, if it's non-V, error. If it's closure V, do the usual function call thingy. If it's cont V, then apply continuation. And I said, burn the bridge, do not go back, you cannot go back to the past. How does that happen? That's the two important things in the implementation of KFAE. The black usual things are just the same, right? But function call and continuation introduction. Let's see. Now, that's why we are looking at function call. In function call, previously in FAE, we interpreted the first sub-expression, and yeah, this is the closure V that we constructed. This is the second closure continuation that we constructed. And we asked FV, hey, are you closure V or not? Or not meaning non-V, it's an error. Closure V, interpret the body expression. With KFAE, what do you expect? The language has changed. What do you expect? Yes, it's gonna have one more case, cont V. And closure V has parameter name, body expression, and the environment when this closure V was constructed. But cont V has one thing. What's that? Cont, which is a lambda expression. So, yeah, when we have closure V, what we usually do is to interpret the body expression on top of the given environment, and then parameter has this argument value, and then when we are done evaluating the body expression, call K. But with this cont V, KV, what are we supposed to do? Meaning that when we have ESC open K, yeah, this is a continuation. What are you supposed to do? Right? That means that we are going to call it. We are going to call that KV. We are going to call KV with what? Argument value. So it's going to be KV with AV. Call K with the argument value. Call K with the argument value. Meaning what? We forget about K. We forget about the remaining work to do. So every time until we get to here with number, what did we do? Call K. With closure V, we call K. With X, get the value from the environment and call K, like that. And finally, when we call K here, continuation, we forget the remaining work. This is what I meant by burn the bridge. We cannot go back to the past and fly out. Control diverter. Meaning we were here, we were supposed to go back in this path, but now we just jump out of it, escape. That's what we talked on Monday. This is the place that we escape. Do you see that? So that's the first point with continuation. How to use continuation? When we have E1 open E2 and E1 is continuation value, then forget the surrounding work to do and just fly out. Get rid of, don't use K, just use this KV. Then how can we make such a K? When we have this introduction of continuation, okay, when we have that, this is what? Open, VCC, X, semicolon, B, close. What was x again? It's a work to do when you're done with this expression. Then when you're done with this expression, you're going to have some value, right? Using the value, do this work. That's this continuation. And using that information, x's value is that continuation, interpret b. Right? So then, what did I say? Interpreting b. Interpret b. Using that information. Interpret this b expression using the information that this x has value continuation on top of this given environment. One more time. This is what? VCC x semicolon b close. We are going to, what's the semantics of that? X's value is the work to do here, and using that information, interpret b. Interpret b. Using which information? On top of the given environment, we extend that information. Which information? X's value is that continuation. X's value is continuation. Which continuation? The work to do next. The work to do next. What is that? The work to do next when we are done with this evaluation is K, right? That's why we have been keeping the continuation K as the last argument. So, yes, interpret B using this environment. Which environment? On top of the given environment, the new name X represents work to the next K. Ooh, that's good. When we are done evaluating this expression, what's the work to do again? When we are done evaluating this expression, the work to do is K. Yes, so this is the semantics. This is the second bit of continuation. How we introduce continuation and how we use continuation. Ooh, is it too much? It's not that difficult, but it's just different. So I'm pretty sure it's not that obvious to you yet, but if you do your project number 2, I'm pretty sure you're gonna have better idea. Now let's take the second break and come back to the last part of first class continuations.